Okay, let's go over homework 4.3, number 5. Right. So this is the given graph. It's a graph of f prime. Right. So we want to find the interval on which the f is increasing. Right. So original function is increasing means that the derivative has to be positive. So we're looking for the graph where it's above the x-axis. So it's going to be between 0 and 2. So put that in. Right, between 0 and 2. Right, and put the union sign. All right, so between 4 and 6 as well. So put between 4 and 6. All right, and you have 8 and on. So I assume that this keeps on going. So take the union. And I'll probably put a here and then put infinity there. All right, so from a to infinity. All right, what interval is f is decreasing? So we know that we were looking for the graph it's below the x-axis. So it's going to be between 2 and 4. So 2 to 4, and take the union. All right, then you have let's see. So below, so yeah, between 6 and 8. So 6 and 8, right? And let's look at the next one, part B. At what value of x does f have a local maximum? All right, so first we have to know where the critical numbers are. All right, so you can see that the derivative 0 at 2 and the derivative 0 at 4. And derivative is actually undefined at 6, so it makes 6 a critical number. And derivative 0 at 8. So they're 2, 4, 6, 8 are critical numbers. All right. Then we're looking for the local maximum. All right. So which means that the derivative has to go from positive to negative. So at 2, positive to negative. So that's exactly what we're looking for, 2. Right? So at 4 is negative to positive. At 6 it's positive to negative, so 6 as well. So put 6 there. Whoops. And that's not where I want. Right? Put 6 there. 8 is negative to positive. So you can see that the 4 and 8 would give you a minimum value. So local minimum. Right? And then part C. One interval is f concave up. Right? If f is concave up, which means that the second derivative is positive, which means that the first derivative is increasing. So we're looking for the graph where it's increasing. Right? Here you can see that it's between 3 and 6 it's increasing, and also 6 and probably to infinity. So let's write that down. Right? So oh, I forgot which one was it. It's a 3 to 6. All right? So between 3 to 6, and then you have 6 and 6 to infinity is right here, right? So infinity. All right, then on what interval is f concave downward? Okay, so concave down means that the first derivative is decreasing between 0 and 3. So I just put that in between so interval from 0 to 3. All right, oops, I don't need that extra. Right, 0 to 3. All right, and part D, what are the x coordinates of the inflection point of f? So inflection point, so we have to look for concavity change. So it's a decreasing, so it's concave down, and increasing, so it's got to be at 3. Here, increasing, there's no concavity change at 6, so only at 3. So only at 3. Right? Oop, just 1. Right? All right, let's see if I did it correctly. So by submitting, and hopefully I got those correctly. So let's test for submit. All right, it takes a while, so I'm going to pause right here. Okay, I came back, and it looks like I got, let's see, the first few, and looks like I got them all. All right, so that's it. I hope that this was clear.